Welcome to operations. This is pretty easy. Basically, they're going to give us two functions. For simplicity's sake, we'll call them f of x equals 2 and g of x equals 3. Now, obviously, it's going to be more complicated than that, but the concept behind everything's the same. Then it wants f plus g of x. Well, we're going to take f of x, and we're going to add g of x, and we're going to simplify. F minus g, take f, subtract g. F times g, take f times g. F divided by g, this one will be a little bit different. There won't be any really like simplifying to do. We'll turn it into a fraction, f divided by g, and then we're going to have to figure out what would make our bottom number 0, because we cannot divide by 0. So if there was an x down here, and this said x plus 2, well, then we would have to then say x cannot be negative 2, because negative 2 plus 2 would be 0. So we'd have to tell them, okay, x can't be this. But it's this simple. So here's their interpretation of what I just said, except they used 2x and negative x plus 5. So f plus g, f minus g, f times g is just distributing, and f divided by g. Oh, look, x cannot be 5 because negative 5 plus 5 would be 0. So here's the first one. F of x is x plus 2, g of x is 3x minus 1. F plus g is added. These parentheses don't matter. Combine like terms, simplify. F minus g. Parentheses kind of matter this time because that's going to distribute and change those signs. Then combine like terms, simplify. F times g. This is just foiling. When they're side by side, this is just fancy foiling. And it's not even really super fancy. You know how to FOIL and simplify from there. F divided by g, like I said, turn it into a fraction. Take this bottom and set it equal to 0 and solve. This is the x that would make the bottom equal 0. The problem is we do not want it to be 0. So the x equals 1/3 I got here was actually the one number x cannot be. X cannot be 1/3 because 1/3 times 3 is 1, 1 minus 1, 0. So take the bottom, set it equals 0 and solve. And just don't come up here and say, oh yeah, x is 1/3 because x is everything except 1/3. Another example. Parentheses don't matter with add. Distribute the negative to subtract. Make sure you combine the like terms. X squared and x don't go together, so they just stay like that. Foiling. This actually didn't have any like terms after we did this. And then here, subtract 8, divide by -1. X equals 8, except again, x just cannot equal 8 because -8 plus 8 would be 0. Let me do this. Let me zoom in a little bit. Three x squared minus 4, 2x squared minus x minus 1. F plus g, easy enough. F minus g, again, easy enough. F times g, you can FOIL here and do your, let me kind of draw it out for you. You can do your moon method. It gets a little sloppy. I don't like it, to be honest. I like the box method. And go back to the factor and FOIL videos at the very, very beginning of this playlist. Combine like terms, get our answer. And f divided by g again. This is some factor and FOIL stuff from the very beginning of the year. Set the bottom equal to 0, but this is just quadratic formula, or in this case, factoring, really easy. And we get our two quote-unquote answers, but these are the two answers that x cannot be. So the book adds one little twist at the very end. It'll say, find f plus g, and then evaluate when x is a certain number. So after you do what we've been doing, you'll then plug in a number for x and get a number, is all it's going to be. So f of x and g of x, when they add, since they're like terms because they have the same radical, it's just negative 3 squared x. When we plug in here, square root of 16 is 4. 4 times negative 3 is negative 12. These look crazy, but this is just subtracting, so that's going to change all the signs of everything. If you put them top and bottom, it's a lot easier to see what has like terms and what doesn't. Simplify, and then it says, tell me when x is negative 1. Please be really careful on your plugging in. Put your numbers in parentheses, especially here. You do this part wrong, your answer will be wrong. But after you figure it out, plug in negative 1. This one has same kind of thing, but evaluate when x equals 4. Well, when you have an exponent and a radical, take the radical and turn it into an exponent. We know how to do that from a couple videos ago. Then when they're side by side, you just add the exponents together. 3 plus 1.5 is 3.5. And improper fraction would say it's 7/2. Then we can write it like this. Either one of those I think is okay. Then evaluate when x is 4. Well, I could do it either way like this, and it'll spit out my answer. And here's my divide. This one was a little tricky. X to the 2/3 on bottom, which is just radical this, or x squared, or cube root of x squared. But if you remember, like rationalizing our denominator a couple videos ago, I need 3 of the same thing, and I have 2, which means I need 1 more. Because 2 plus 1 gets me 3. The cube root of something 3 is just the x. Well, here up top, you just put 4x times the cube root of x. Well, these x's actually cancel, but here's the deal. X cannot be 0. Initially, x cannot be 0. Because when you set it up here, you kind of go back to the original. Even though this will end up canceling out, x cannot be 0. Because the 27 and 27, when we plug in x is 27, they do cancel, but we still are dividing by 27 technically. So x can't be 0. The bottom still cannot be 0. And that's really all the book has. It's not too crazy. Add them, subtract them, multiply them. Then divide is just set up as a fraction, and then set the bottom equal to 0. Tell me what the bottom cannot be. But yeah, that's about it.